In this video, I want to briefly go over section 14.3 and what causes some local and regional winds. We'll focus on the local winds. And I bring you back to this drawing that we produced in chapter 13 that ultimately dealt with the differences in specific heat and heat capacity for water and land. And I mentioned that this difference in warming and cooling of the Earth's surface, whether it's water or land, gives us things such as sea breezes or land breezes. So we said that this difference in heating during the day causes air to rise over land and air actually to sink over the oceans, notably in coastal areas. And so with respect to things that you learned about air pressure and the causes of wind, that winds will travel towards areas of low pressure, this entire area during the day, let me use a different color, is an area of low pressure near the coasts. Low pressure because this area is warm and it's rising. It's expanding in volume, so pressure is decreasing. Areas where atmosphere is falling or sinking are areas of high pressure. And so during the day, the coastal land region becomes areas of low pressure, in other words, being rising air, and high pressure being sinking air. And winds blow onto land, and this is, of course, responsible for a lot of the humidity that we feel. And then overnight, we have, let me draw the same thing, except because land cools down faster than water, we will have sinking air over land and rising air over the oceans. And so we have low pressure over the oceans and high pressure over land. With respect to the Earth as a whole, let me double check something. With respect to the Earth as a whole, we have some major wind groups. First and foremost, we should probably talk about the Coriolis effect. So here's the Earth. Let me draw it in black. Yes. Here's the Earth. Nope, that is not black. That is red. Or green. There is the Earth. You can see it. Absolutely. The Earth is rotating. But the land is rotating as well as the atmosphere. But the land and atmosphere are rotating at slightly different rates. And so there tends to be a drag that is most pronounced at the equator and least pronounced at the polar regions. And the responses for a rotation of winds that's dependent on whether you're north or south of the equator. If you're north of the equator, the rotation is in a clockwise direction, and if you're in the southern hemisphere, the rotation is in a counterclockwise direction. As a result, air is kind of moving in two directions, both horizontally and vertically. So we can look at the whole Earth right here. And we have several important levels, say 0 degrees, 30 degrees, 60 degrees, and of course 90 degrees. 30 degrees, 60 degrees, and 90 degrees being the North Pole and the South Pole, and 0 degrees being the equator. Let's start talking about the vertical. So we're actually going to show the vertical on this slide, or on this side of the planet. And to kind of document and pay attention to this, we need to remember from our last chapter property of insolation. Insolation is the amount of energy being received from the sun, and that is insolation is going to be highest in areas that are receiving direct sunlight, or sunlight during the middle of the day. The sun is directly above your head. So that would be associated with equatorial regions, whereas polar regions are receiving the lowest amount of sunlight, of direct incidental sunlight. So there's a gradient of maximum insolation to minimum insolation at the poles. Based on what we talked about at the beginning of this video, direct heating causes a rising of air, or high pressure. I'm sorry, or low pressure is what that is. So we actually develop a low pressure system close to the equator, and that low pressure system results in air rising and moving away from this area of low pressure, either north or south, where it eventually sinks at about 30 degrees. And we develop two types of cells right here. These are called Hadley cells. And areas of low pressure, we'll learn here in a little bit, are responsible for lots of rain. Rising moist air is responsible for a lot of rain. So this is why equatorial regions are typically associated with rainforests. You have the Amazon rainforests, as well as rainforests in Central Africa that are typical of 0 degrees Celsius. So we can write rainforest there across the equator. Most typically, there are going to be some fluctuations to this that we'll see, but this is a big driver for the location of rainforests at our equatorial regions. Now, at the polar regions, at the subtropical regions, temperate regions, we have the development, and this is actually a fairly weak development right here, which we'll talk about later in either this chapter or this semester, there's a very weak cell in this section right here. And that is associated, if this was a low pressure system, we have a high pressure system associated with the falling air that you see right here on both sides. And this falling air at 30 degrees north or 30 degrees south is associated with desert, most typically. If you were to look at a map of Africa, you'd see the Saharan desert, the Arabian desert, a lot of the deserts in the Middle East and Asia are associated with being 30 degrees north or 30 degrees south of the equator. Houston is about 30 degrees north of the equator, and we are far from being a desert, particularly this week. However, as I said, there are local effects that can play an important part, notably our global position with respect to the Gulf of Mexico and the moisture that it generates, and plays an important part in the Houston area not being desert-like, but certainly further inland, even towards the west, such as West Texas, you have desert situations. 60 degrees north, at 60 degrees north, you actually have two sets of rising air, one that we just drew, let's see here, rising air again. And rising air is associated with low pressure systems, and this is also associated with high concentrations of rain. Case in point, Seattle and the Pacific Northwest regularly receive a lot of rain. This is due in part to regular rising air conditions in that area. And again, these are generalizations globally. And then finally, the poles. Well, these are fairly well-developed cells near the poles, so they have names, polar cells, as opposed to these between 30 and 60 degrees, that they are not well-developed, but polar cells are well-developed. They're responsible for rainforests and large amounts of precipitation north and south, 60 degrees of the equator. But the polar regions, you can see, are associated with falling air on both fronts. And as such, we always say that falling air is associated with a high pressure system. And high pressure system, just like high pressure system at 30 degrees, is desert. Now, we usually don't think of Antarctica or the Arctic being desert because we see all of that snow. However, all of that snow is accumulated over thousands and tens of thousands, and in the case of the Arctic, millions of years, forming glacial ice. But what defines a desert is the amount of precipitation received in a location over a given year. And it snows very little within the polar regions because of constant high pressure conditions, near constant high pressure conditions. Finally, within these zones as well, you have some important wind patterns. You have surface winds, within 30 and 0 degrees, called the northeast, trade winds. They're called the trade winds because back in the days of sailing, these were winds that carried ships quickly across the Atlantic Basin or the Atlantic Ocean. And the shape of these is directly related to the Coriolis effect. And between 30 and 60 degrees, we have the westerlies. Now, why the northeast and why westerly? Recall from the reading, if you've already read it, that the names of winds are designated by the direction they're coming from. So northeast trade winds aren't the direction that they're blowing, it's the direction that they're coming from. And westerlies are so named because they're coming from the west. Similarly, south of the equator, we have southeast trade winds. Southeast trade winds. And we have a southern hemisphere set of westerlies as well.